Welcome folks to our lesson 3 on practicals. Okay, so we have to sharpen our skills. Okay, we have to sharpen our skills in practicals. Practicals essentially is hands-on activity where you can make some observation. You have to know how to record and to make inferences. Under this observation, what is it do I learn? But I want you to kind of list these things down and you go through them one by one. Some I will have to repeat, okay? But in a nutshell, what are the skills that are tested in practicals? One is reading of devices. You have devices like measurement devices. Measurement. We have length, we have mass, we have time. Remember Form 1? Yes, you learned those ones. Basic quantities. So if you just throw away the notes of Form 1, you're in trouble. Okay? We have basic quantities. And we have devices that we use to measure those quantities. So you have time, stopwatch. You must know how to use a stopwatch. Start, stop, reset. And people confuse the readings, but that is something special on a particular day on its own. So we have to test the measurement of quantities. We have to test how do you carry the experiment, the hands-on. Is it a successful experiment or is it a failure? Okay, we have to test graph work in that, because inferences. What does it mean when a pointer deflects? Do you know how to record the figures? Do you know how to manipulate them? For example, I can record the time for 10 oscillations, but do you know how to get periodic time? Can you get square of periodic time? Whether the entry is wrong, that is you are computing. You should be able to get, if I get 4 squared, that is 16. So try to get these things right. Okay? When you have the basic skills, you are able to navigate easily. In practicals, you are also told, take 15 minutes reading. What essentially do you do in such a period? In such a period, you read to figure out the experiment. At the end of question 1 or 2, sometimes you get some equations. Okay? Those equations are a pointer to the kind of quantities you will record. Because if the equation given is related to y is equal to mx plus c, then you should know it's likely you are going to get a linear graph. Okay? But slowly I'll take you through each skill. But now I want you just to, we focus on the board, you get this basic. Okay? Get basic. And then we shall be doing one by one. Okay? So let us focus on the screen. I see if you can have something to write. Number 1, if we are dealing with electricity. But number 1 applies to all, whether optics, optics, whether electricity, whether heat, you see, whether mechanics, okay, It doesn't matter. Number 1 applies to all of them. Arrange apparatus as drawn. Some students even draw on the desk. You are wasting time to draw on the desk. The paper is already there. So what do? You just arrange the way they are. Look at a question like this. Look at a question like this. Okay. A question like that. This question tells you there is P1, there is P2. Those are the points, pins you will make. Then in the explanation, it tells you need to put P3, P4. Now you can see these ones are put on the side AC. So this is the range of your observation from A all up to C. If you extend this and extend that, it is really, that is the range of observation. Arrange the way it is drawn. Now, this is a triangular prism. Some people will put a square base, whereas you've seen the diagram here is triangular. So arrange the way it is drawn. Do not arrange according to your understanding. 2, confirm workability. Confirm workability. For example, I can give you in the diagram, in the table, you have been given different lengths. Our stand, then the stand we use in the lab is not yet even 1 meter. And he wants you to use or to carry out an experiment where on the table there is a length of 100 centimeters. Now, even if you arrange, number 2 now tests you that it has to be workable. It has to be carried out. So what do? I arrange my setup, the stand, such that when I tie the string, the bob will be freely at the edge. Do you get me? At the edge. So if this is my bench, then it can swing freely beyond the edge. This is my bench. So the stand would be somewhere here, but the string can come. Okay? Now that's what I mean by confirm workability. Is it working? Can it work? 3, identify loops. Now this is electricity. This is electricity, okay? So in electricity, confirm workability. Make sure all like the bulb, that is where I can give an example. You must make sure the bulb is tight. I wish I had a bulb. Okay? You tighten the bulb. You make sure that that bulb is going to work. You already learned in Form 1, current cannot flow through in complete circuit. And you have been given the bulb, you have not confirmed if it is tight. So definitely it is going to fail. And then you will wonder, you will start getting pressure. So since it is electricity, I give a general view, but I must come back to electricity. See that it is workable. See that if you have a voltmeter, is having the pins that are tight enough. They are tight enough. They are not loose. Because anything loose in electricity, you are not going to get the answers. Number 3, loops. Loops. What I mean by loops are simple questions. Maybe I use this example here, like this. You see, there is a loop here. And then there is this loop. Okay, that is what I call as a loop. And even this is a loop. So to simplify your work, what will you do? Connect voltmeter and leave it. If I connect the voltmeter and leave it, just imagine you don't have this now. You don't have this. Then it means you have just this one loop. Get me right? I've identified here, there are like two loops. So there is this. Ni kama mzunguko. If you want to understand mzunguko. Unaona, nikitoka hapa nitazunguka nirudi. Huo ni mzunguko moja. Lakini even here kuna mzunguko. So those are the ones I'm referring as loops. Now, like in this case we have two loops. So what do I do? Connect the terminals of a voltmeter and leave it. The moment I do that, I remain with one loop. Okay? So now, after connecting the voltmeter, leave it. Put it aside. In other words, that part of the diagram is like it is not there. So it has left us with one loop. So connect the loop. So I start connecting the loop that remained, and then I come and finish with the voltmeter. Okay? Then see deflection on meters. The two meters that are commonly tested are ammeter or millimeter and voltmeter. Ammeter, millimeter, and voltmeter. Okay? So these two, you don't need to cram. When you come to school to the lab, do not cram but understand what is happening. Okay? Now, in the meters, other than these two common meters, we also have a zero-centered galvanometer. A zero-centered galvanometer. Okay? Now, you can see I have two sides with similar readings. Two sides with similar reading. It's like a number line but without negative. Essentially, a galvanometer can deflect on one side, and after some action, the opposite action, it deflects on the opposite side. Okay? So that when you have zero-centered galvanometer, something should click in your mind. There is likely to be a deflection, maybe on the left, and in another scenario, it has to deflect to the right. That is its work. And especially when you have things like capacitor, because there is an action of charging and discharge. Now, if I have that theory, it backs me. I want to focus the camera down so that I deal with something here, which I said you don't need to cram. When you are dealing with ammeter and voltmeter, look, after you have connected your loop and you find out the pointer is below zero where there is no scale, then you change the terminals. Where there was positive, take it to negative, negative, take it to positive. Even the ammeter and the voltmeter itself, okay? If it is an ammeter, whatever was connected here can go here, and from here can come here. So you do it once at a given device with polarity. I can do it at the source, because the source also has polarity, positive and negative. Right? So let us begin understanding troubleshooting and its correction. So if I get a deflection below zero, it is changing the terminals. Whatever was on red, bring here, and black, take it there. Okay? Then number two, if your connection happens to be within the scale, I've just shown you 0 to 5. If it deflects here, then correct wiring. you did the correct connections. What about if it deflects beyond 5? It requires a larger scale. It requires a larger scale. So let me also find something here again. Number 7, series and parallel connection are very important, because in electricity, sometimes we are asked to connect in series. So you have a cell, for example, connected to another cell. But if it is in parallel, you have a cell and another cell. These two should be connected, and these two should be connected, and then now your terminals operate from there. Okay, very important. So you take a clip, connect this and that. So negative and negative, then positive and positive. Then from there you can carry out now your connection. Then lastly, capacitor, potentiometer, variable resistor. Capacitor. A capacitor is a device that looks like this. Okay? That. And a capacitor has a reading like there. You can see 4700 microfarad. Even this is written 2200 microfarad. So the capacitor has its capacitance written on it. Sometimes you get a question for 1 mark. Write down the capacitance. And you find students cannot even get, yet it is written. The same thing when we are giving lenses, there is the housing of the lens, kamfuko, ka lens. On that kamfuko, the focal length is written, and you find somebody has left the focal length blank. So even if you didn't know, you should be able to write that. Those are things that you have to develop. Just open your mind and get. Then let me come to potentiometer and a variable resistor. Okay? Potentiometer and a variable resistor. I conclude a potentiometer and a variable resistor. We have this device. You must have seen it. Okay? This is 2-in-1. It is a variable resistor, at the same time is potentiometer. So what is the difference? A variable resistor has 2 terminals. A potentiometer has 3 terminals. So let me see if I can get some space here. Write down. I hope I get down. I can get some space there. Yeah. So that I can write here. If I have this, that is a variable resistor. Now, which are the 2 terminals I'm talking about? I'm talking about A and B. That is where your connection must be. A and B. Okay? I think since this is very important, I better just rub this and show you the right way. Okay? So I have there a variable resistor, terminal B, terminal A. That is a variable resistor. 2 terminals. So 2 terminals. But when I draw for you something like this, then that is a potentiometer. So this is potentiometer. So what does it mean in a nutshell? Even if I gave you this, which is 2-in-1, this is 2 in 1. It can act as a variable resistor and it can act as a potentiometer. Potentiometer must have connection 1, 2, 3. If it is operating as a variable resistor, then there can be 2, either this or that, for the reason I will explain. It can be either this or that. And they are of various sizes. The most common that you encounter in a school is this. You can see the 3 terminals, 1, 2, 3. So get me right. A variable resistor, you will use either 1, 2 or 2, 3. 1, 2 or 2, 3. Okay? So, here, there, there. So you will use 1, 2, 3 potentiometer. But if I'm using this 1, 2, 3, use 1, 2 or 2, 3, and I will explain why. Okay, I'll show you why do you use that. Okay, now if you are lucky, the teacher will have can dismantle this so that you see the inside. So the inside, how does it look like? The inside, okay? The inside is basically some wires, okay? Some wires is basically some wires that are wound. If I may have this, okay? So, there. So you have some wires. There. Okay? And then, now that is terminal 1, that is terminal 3. And then you have something that will be movable. You see, the top moves this. As it moves this, it has a plate inside. So that plate can connect up to there. Okay? That is a plate. So this is 2. So if I connect 1 and 2, I'm operating with this length. So if I keep on rotating the knob then it can keep on going, meaning that it varies length. So you can see my connection is either 1, 2, or even if I use 2, 3, is the same from the other angle. Okay? So this is a variable resistor. It allows for variation of length of a resistor. Variable resistor. That wire is a resistor. When we say vary the wire, vary the length of the wire, so we call it variable resistor. A resistor which can be varied, but there are some resistors that cannot be varied. You must have seen you must have seen something like this, okay? Something like this with the color code. That is not a variable resistor. It has a fixed resistance. Okay? So I hope you get a slight difference. Variable resistor. Basically, there is a wire you are going to use, but your practical will require different lengths. Variable resistor. Okay? Folks, those are basics. So I'll pick an example the next lesson, lesson 4, so that I go through what I have said. Please subscribe and tell another friend, subscribe. I need some people to subscribe, not just to watch. Subscribe for more. You will get a notification. Lesson 4. Bye bye.